Assalamualaikum and hi everyone. So today we're going to do the mechanism for haloalkanes. There are two types of mechanism, which are SN1 and SN2. SN1 will favor the most hindered haloalkane, which in this case the tertiary point, while SN2 will favor the least hindered haloalkane, which is in this case the primary. So now I'm going to show you the SN1 mechanism. SN1 stands for unimolecular nucleophilic substitution due to the rate law, which is the first order. So we're going to use this reaction. We have this as an electrophile, while this one will become the nucleophile due to the presence of lone pair and will form the tertiary alcohol. So this mechanism will involve two steps. The first one is formation of carbocation. So this is our tertiary structure, the most hindered carbon. This carbon is attached to three different alkyl group, or maybe the same alkyl group. The carbon in here, which bearing the Br, which is our halogen, is a polar bond. Due to the electronegativity of this Br, will somehow affect this carbon to become electron deficient species. Therefore, we'll have partially positive and partially negative in here. So this bond will break and undergo the rate determining step, which rate determining step is a slow process. Then will become our designated product, which is the carbocation. And the Br negative. This step is a slow step, which we call it as rate determining step. The rate of reaction will involve only the concentration of haloalkane. So the second step, we call it as nucleophilic attack. During this step, the nucleophile will attack this carbocation. So we have our carbocation in here, and then we have this as our nucleophile. So the lone pair in here will be donated to this C, forming our product, which will undergo the fast reaction to form a species with protonated alcohol. Because we haven't got our final product, then we have to react again with the water. This lone pair will take this H out and break this bond. Lastly, we'll get our final product, which is the alcohol. And H3O+. Don't forget to include your lone pair in here, because initially you have two lone pairs. Here is the overview of the SN1 mechanism. Now, the SN2 mechanism stands for bimolecular nucleophilic substitution. This mechanism involves only one step, and strong nucleophile is required for this reaction to occur, such as OH-, CN-, and OR-. The rate determining steps will involve the concentration of haloalkane and nucleophile. So we are going to use this reaction. We have to show SN2 mechanism using 3D structures like this. So in here, we have the carbon bearing the Cl-, which will become the electrophilic site. The nucleophile will attack from the opposite side of the halogen. This bond will break and form the intermediate product, which we call it as transition state. There are two phenomena happening at once. First, carbon will partially form a bond with Cn, and at the same time, the carbon will partially break the bond with the Cl. The conformation of this structure is now a trigonal planar. After the bond breaking, Cn will fully bonded to the carbon and form an inverse conformation. plus Cl minus. So this is our final product for this mechanism. So here is the overview of the SN2 mechanism. Thank you. Hope you enjoyed this video. Happy learning!